Algebraic Reasoning, Chapter 1.7, Exercise 1 through 12. This section 1.7 of the book has to do with quadratic functions, and specifically for questions 1 through 6, determine whether the set of data represents a linear, quadratic, or exponential function. And so thus far, we have gone over in the course linear, exponential, and quadratic functions. So now we're going to use this compilation of skills developed thus far to determine which of these functions in table form are which. And we can see on the left side of our table here that we are going up by increments of 1, which will help us in our analysis. And we are going to first go to our first differences. And our first differences we get by subtracting one term from another. So 16 minus 7 is going to be 9. 27 minus 16, that's going to be 11. 40 minus 27 is going to be 13. And then 55 minus 40 is going to be plus 15. And we see that for this one, we definitely do not have linear. So first differences are not equal, not linear. So I'll just write this down. First differences are not equal. Not linear. Next, we're going to go to second differences. And if we do that, we have 11 minus 9, which is plus 2. We have 13 minus 11, which is plus 2. And we have 15 minus 13, which is plus 2. So we have, in this case, second differences are equal to 2. And just because we do have a second difference that is common, we say, we'll say, I'll word this way, common second difference means quadratic. So we will go ahead and box this in as our correct answer for problem number 1. In this set, I'm going to do the odd number problems 1, 3, 5, 7, 9, 11. So let's go over to our next odd number, 3. We're going to put forth a similar analysis. And to do that, I'm going to look first to first differences. So we have negative 28 minus negative 13. Let me just write this down. Negative 28 minus negative 13, which equals negative 28 plus 13. And negative 28 plus 13 should be negative 15. So negative 15. Next we have negative 45. We're dealing with negative numbers. That can be problematic, but we're going to have negative 45 minus negative 28 which is going to be equal to negative 45 plus 28. And that's going to be negative 17. So negative 17 is going to be another difference. Next, we're going to have negative 64 minus negative 45, which equals negative 64 plus 45, which equals negative 19. I think we can probably see where this is going. Next, we have negative 85 minus negative 64, which equals negative 85 plus 64, which equals negative 21. So here we have, similar to number 1, first differences not equal. So we say not linear. Next, we're going to go to second differences. Okay, I'm going to just work below. We're going to have negative 17 minus negative 15, which equals negative 17 plus 15, which equals negative 2. So negative 2. Next, we have negative 19 minus negative 17, which equals negative 19 plus 17. What is that? Negative 2. And lastly, we have negative 21 minus negative 19, which equals negative 21 plus 19, which equals negative 2. So, second differences. Exist and equal, in this case, negative 2. Conclusion, quadratic function. So we're going to box this in here. We did for number 1. Okay, next on our problem 5. Look at a similar type of analysis as to what we did earlier. Okay, first one we have negative 6 minus negative 4, which equals negative 6 plus 4 equals negative 2. So we go to negative 2 is our first difference. Next, we're going to have negative 6 minus negative 6. Well, that's going to be plus 0. Next, we're going to have negative 4 minus negative 6, which equals negative 4 plus 6, which equals 2. So plus 2. And the last one, we're going to have 0 minus negative 4, which is going to be plus 4. So these will be our first differences. Not equal. Therefore, not linear. Next, we're going to do as we did similarly in 1 and 3 and take our second differences. 0 minus -2 is going to be plus 2. 2 minus 0 is plus 2. And 4 minus 2 is plus 2. Okay, so we have second differences are equal. Get that here. Are equal. We have a quadratic function. Now, in this exercise set so far, I've done the odd ones, 1, 5, 1, 3, and 5, and they all turned out to be quadratic. And I just want to look around in this set to see if the even number ones we didn't look at, just at a glance, would be something other than, let's see, for 2, looks like we're going up by 3 each time, so 2 looks like it might be linear. 4 looks like we're going up by 2, 4, 8. So 4 looks like probably exponential. Okay, and then I don't know, 6, we have to look at, see, it might be exponential. All right. Anyway, let's go over this next set, 7 through 12. Use the data set to generate a quadratic function that best models the data. So now for this set, we're told that these are quadratic functions. So we're going to go to our first differences first. And then we're going to have to know have to remember the rules there for creating quadratic functions. So first differences, we have 12 minus 3, so we're going to have plus 9. And then we're going to have 27 minus 12. 27 minus 12 is going to be plus 15. And 48 minus 27 will be plus 21. And then 75 minus 48. Let's see, what is that going to be? Is that going to be 27? Yeah, plus 27. So these are I'll just identify these as first differences, which not quadratic, definitely, because that's what we designed it to be. And what I'm going to do is kind of arrange that and put the label here at the bottom, and you're going to see why after a bit. First differences. Next, let's go to our second differences, because that's what's going to really get us into what the essence of this quadratic function. Okay, we have 15 minus 9 is going to be plus 6. And then 21 minus 15 is plus 6. 27 minus 21 is plus 6. So we have, according to the rules of creating quadratic functions, we have our second difference are equal to 2a. So our second difference is 6. I'm going to just label that as such here. Second differences. So 2a equals 6. So dividing by 2, a is equal to 3. Okay, so I'll just put this over here. A is equal to 3. Next, the y-intercept is going to be where x equals 0, and we don't have that up here, so I'm going to extend up above. And the first thing I'm going to do is take a second difference backwards to get this first difference up here. So if we say this is plus 6, what plus 6 equals 9? Okay, what plus 6 equals 9? Well, I would say plus 3 plus 6 equals 9, right? Okay, so that would be our first difference. And then if we go backwards and we say 3 minus 3, when x equals 0, y should equal 0. So therefore, we would say our y-intercept is 0, and therefore c is equal to 0. Okay, next, to find b, the difference between y values where x equals 1 and x equals 0 is b plus a. So if we just go backwards here, we say, okay, our difference is going to be 3, so we say 3 equals b plus a. And if a equals 3, we say 3 equals b plus 3. Well, subtracting 3, we have b is equal to 0. So I'll put b equals 0 up here. So accordingly, we have f of x equals ax squared plus bx plus c. We would have, for this specific instance, fx equals 3, since a is 3, x squared, and plus bx, well, b is 0, plus c, c is 0. So this would be our function. And we could just test it out. Okay. If we say 1, we plug in 1 times 1 squared times 3, that's 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. 4 squared is 16 times 3 is 48. And finally, 5 squared is 25 times 3. So this would be our correct quadratic function. F of x equals 3x squared. Next, we're going to go to problem 9. Okay, same type of strategy. We go to our first differences. We do not have a y-intercept yet, because we don't have where x equals 0. We should be able to get to it. So the first one we're going to have, our first difference is going to be negative 20 minus negative 12, which equals negative 20 plus 12, which equals negative 8. Negative 8 is our first difference. We're going to have next negative 24 minus negative 20, which is going to be negative 4. We're going to have negative 24 minus negative 24, which is 0. And finally, our last first difference is going to be negative 20 minus negative 24, which is going to be plus 4. So these will be our first differences. Next, our second differences, we're going to just go like this. It should be quite apparent. -4 minus -8 is going to be plus 4. 0 minus -4 is plus 4. And 4 minus 0 is plus 4. So these will consist of our second differences. So our second differences is equal to 2a. And so 4 is equal to 2a divided by 2. We say a is equal to 2. So I'm going to write that down here. A is equal to 2. Next, we're going to go backwards as we've done before. So what number do we have to add to get for a first difference? What first difference do we need that when we add 4 to it, we get -8? Well, that number would be -12. Okay, so that's going to be a first difference. Okay, and now to go backwards, what number do we add -12 to get -12? Well, that's going to be 0, right? So 0 plus -12 is going to be -12. So that's going to give us a y-intercept, or c, is equal to 0. Next, we have the differences between the first difference and the second difference. So difference between y values where x equals 1 and x equals 0 is a plus b. So that's going to be -12 minus 0. So -12 is equal to a plus b. And so -12 is equal to 2 plus b. And subtracting 2, we're going to get b is equal to -14. So I'm going to say b is equal to -14. So in our form here, we're going to say f of x is equal to ax squared, which is going to be 2x squared, plus 14 plus bx, which would be minus 14x, plus c, and c is 0. So now we can just put our values in to see what we get. If we try 1, just to test, we say f of 1, we should get 2 times 1 squared minus 14 times 1. So that'd be 2 minus 14, which is equal to -12. So that would check out. Let's try one more, f of 2. F of 2, we're going to say 2 times 2 squared minus 14 times 2. So that's going to be 2 times 2 squared is going to be 8 minus 28, which equals negative 20. Is that right? Yes. So we've made a couple of tries, and that's what we get. So it looks like we verified that our function is going to be this one, f of x equals 2x squared minus 14x. Okay, next and really last one that I'm going to work on this video lesson is going to be number 11. And let's go to the first differences. And we're going up by ones here on the left, so that's consistent. So negative 8 minus 1 is going to be negative 9. We're going to have, for this next one, negative 23 minus negative 8, which is going to be negative 23 plus 8, which is going to be equal to negative 15. So we get negative 15. That's our second first difference. And then we're going to have negative 44 minus negative 23. That's going to be negative 21. And the last one here, we're going to have negative 71 minus negative 44. That's going to be negative 27. So these will be our first differences. Next, we go to our second differences. So the second difference we're going to have is negative 15 minus negative 9. It's going to be negative 15 plus 9, which equals negative 6. So we get negative 6. Next one, we have negative 21 minus negative 15. That's also going to be negative 6. Last one is negative 27 minus negative 21, which is negative 6. So these will be our second differences. And according to our equation, I'm going to put this at the right here. We're going to have second differences are going to be equal to 2a. So we have negative 6 is equal to 2a. Dividing by 2, we have a is equal to negative 3. So I'm going to put over here, up here, a is equal to negative 3. Now we're going to work backwards to look for our y-intercept. And going back, our second difference of negative 6, coming back, so what minus 6 is going to equal negative 9? Well, I believe that's going to be negative 3. Okay, and so that's going to be our first difference. Negative 3, our first difference. And to go back to 0, I'm going to put 0 up here above that x. So what minus 3 is going to equal 1? Well, that should be 4, right? So 4 minus 3 equals 1. We subtract 9 more, get negative 8. So that holds. So since our y-intercept is 0, we would say, our y-intercept is 4, we would say c is equal to 4. Next, the last one, we have the difference between y values where x equals 1 and x equals 0 is a plus b. And so we would take, all right, the first difference would be -3, right? So we would say -3 is equal to a plus b. And we've already figured out that a is -3. So -3 is equal to -3 plus b. Adding 3 to both sides, we would have b is equal to 0. So I'm going to put b is equal to 0. Now we can just try this out. We're going to get, accordingly, f of x equals ax squared. Well, a is -3, x squared. We have b is equal to 0, and so we're going to have c is going to be plus 4. So really, that should be it, and we can just try these out. Obviously, if we test our y-intercept, say f of 0 is going to be equal to 4, because we have 4 left there. That checks what we have. F of 1, if we plug in 1, we're going to have -3 times 1 squared plus 4, and that's going to be -3 plus 4 equals 1. So that checks out. Let's try one more. F of 2 is going to be -3 times 2 squared plus 4, and that's going to be, I'm going to put down here -12 plus 4, which equals -8. Check. So we've done 3 checks here. So that really verifies that our function here is going to be quadratic function f of x equals -3x squared plus 4. So good luck. Remember these rules, and that's pretty simple to create quadratic functions from data in a table. Good luck, and thanks for viewing.